Hey everybody, how's it going? I recently discovered a new technology called YOLO. If you don't know what YOLO is, it's a family of models that allow you to perform computer vision. So in this video, we're going to build a project where if you give the model a picture of a few coins, then I want my model to tell me how many coins I have according to each denomination. Sorry, I meant denomination. Anyways, so for example, I want my model to tell me that I have one 2-cent coin, one 5-cent coin, and one 1-cent coin. So let's get started. So my first step here would be to get my dataset first. So this dataset is just gonna be a folder with many images. So as discussed in my video, I'm gonna train my model on my YOLO coins dataset. You are free to use your collection of images that you want, but luckily I found a dataset off of Kaggle that I will download now. So I'll download like so. So download and then download dataset as zip. So now that I have gathered all of my images, I would now need to annotate them. My model can learn from my annotation and then it can detect what kind of coin I have. For annotation, I'm going to use something called Label Studio. So to download Label Studio, make sure you have a virtual environment already running or already activated. So to install it, I go pip install-u label-studio. I've already installed it, but make sure you install it on your own PC. Anyways, to run Label Studio, I just go label-studio. And now we have to wait for a bit for it to start. Alright, so after a bit, Label Studio has now opened up. So let's first create a project. So I click on Create Project. So first, I would have to create my project name. So I go Tutorial, or better name would be Coins Tutorial. And then Data Import. I upload my files. So then here, I would have to bring in my files. So it's important to remember that Label Studio, it will accept up to 100 images. So then first I select the first 100 images up till 100.jpg, open, and then for the remaining 50 images, so 101 till 150, open. And then here my next step would be to perform my labeling setup. So I go to labeling setup. Since I want bounding boxes, I'll select object detection with bounding boxes, and here we can add a label names. So in our case, we're going to have 1 cent first, then we're going to have 2 cent, new line, 5 cent, 10 cent, enter, one more, 20 cent, 50 cent, 1 euro, 2 euro. So let me double check if I have all of my coins and their denomination. So then to add my label, I'm just going to go add. So as you can see, now my labels have been added, but there are 2 labels that I don't really need. To remove them, I can go to code. So the first 2 labels are here. I just remove them and then I save. That's it. Let's now start with the annotation process. So I'm going to click on my first image, and to annotate this image, I can first zoom in a couple of times and then I can use the pan button to pan. And then to annotate, for example, my 2 cent coin, I can click on 2 cent and then we can draw a bounding box like so. Okay, so now with my bounding box drawn, there's some extra space. I can just trim it like so. I have to be a bit accurate here and here as well. And then when I'm done labeling, I just press escape. So same for my 5 cent coin. I draw a bounding box like so. Here's some extra space. Escape once again. And I'll do the same process for my 1 cent coin. So 1 cent. I need some extra space this time. I'll expand this box from here and then from here, and I have extra space here, so I'll remove it. So now I'm done with this image. So I click on submit. Great, I'm now done with this image. Here I would advise you guys to finish your labeling process with all of these images. So now assuming that you're done with labeling your whole project, we can go to Coins Tutorial. So now we need to export it so that we can use this data set for our YOLO model. So I do export, I scroll down and then I go to YOLO with images and then I do export. So now I'll open my file explorer and then let's see how the dataset looks like. So within my dataset folder, I have my classes.txt file, which are all of my classes. Then we have my notes.json file. So I have my class name and its corresponding ID. And let me close it. And then we have our labels. So in this case, we just labeled one image. So I have my one image and I go to labels and I have my labels like so. So in this case, my first character is going to be my class ID. And then my next four numbers, as you can see here, these are coordinates for my bounding box. So luckily, before recording this video, I've already built a data set and I've already annotated all of my 150 images. Let's now go to Google Colab where we can use this data set and train our model. So now that I have my data set, I would need to upload it to Google Colab. I would first compress it so that it's faster to upload. So I'll compress and then I'll upload it like so. So while it uploads, we can write some code to divide this data set into test and train data sets. So luckily I found some code here. It's from another tutorial I saw. So let me just copy this and I'll go back. I'll paste it here. Of course, I will link my sources in the description. So anyways, let's double check this code. So I don't need any arguments since this is not a CLI tool that we're building. So I'll remove this. And then for my variables, so for my data path, it's going to be ./archive. And then my train percentage. So what ratio is going to be my train data set and what ratio is going to be my validation data set. So I'll set it to 0.9. So I want 90% of my data set to be in the train folder. So scrolling down, we can see that this code is dividing both the images and the labels into the respective data sets. That's exactly what we need. Okay, so this code looks fine for now. I will now unzip my archive.zip file. So I go unzip -d. Actually, let's leave out -d, unzip archive.zip. So if I refresh, I now have a folder called archive. So let's run it. Okay, so now if I refresh, we now have a folder called data. Here we can see we have two folders, train, which should have around 135 files, and we should have validation, which should have around 15 files. And we have our images and we have our labels just as expected. Let's now move on. So when we train our YOLO model, we should have a .yml file which contains all of our settings for our dataset. So for example, our path, the path to our train folder, the path to our validation folder, along with the class names. So again, I found a script that does that for me. So here I just copy it like so and I paste it here. So in this piece of code, all it's doing is it's reading from the classes.txt file, which is located within my archive folder. It writes those classes to my YAML file along with my additional settings. So anyways, we have an argument path to classes. So the function that calls it, I go ./archive/ or basically it's already there. So I'll just do like so ./archive/classes.txt. And the path to data.yml, yeah, this seems fine as well. I'll remove here path to classes text, and let's double check all the code that we need. So here we don't really need the NC field, so I can just remove it like so. And yeah, so far it seems fine. Let's now run it. Okay, so now that we've run it, we can see the contents of our file. However, there's one thing that's slightly incorrect. So for example, we have a class ID of 0 and then the class name, but here we don't have our class ID. So what I can do here is I can fix the code. So we can create a dictionary like so. So I go class dict. So I want my class ID and then my class name. So I can go something like I is name. So the key and the value for I, comma, name in enumerate classes. If it's unclear to you, you'll know what I mean in a second. Anyways, I'll now pass class dict instead of classes. So hopefully this should work. This exactly matches the schema that we need. Let's now move on. So here, my next step would be to install the dependencies for YOLO. So I go pip install. So there's only one dependency called ultralytics, and then I run it. So while it runs, we can create another code snippet, and here I would actually train my model. So I go from ultralytics. So now we have the ultralytics library, import YOLO. So I import everything related to my YOLO model. So first I would have to load a pre-trained model. So I go model, YOLO, and then my model name. So YOLO 11n.pt, and then I would have to train my model. So results, model.train. The first argument is going to be data. So the path to my data.yml file. So I'm going to go data.yml. Let me close it. I need more space. Then epochs, so 200, let's say, and then my image size, let's say 640. So here it doesn't really mean that your image size should be 640 by 640. So for example, our images here are 720 by 960. It just means that our image or our data set will be resized to 640 by 640. And it tries to preserve the aspect ratio by padding the image. Now that we have written our code, let's run it. Okay, so now it seems to be training the model. Let's wait for a bit. All right, so now we're done here. Let's now write some more code to validate our model. So I do again model YOLO, but instead of importing our YOLO 11n model, we're gonna import our trained model. So according to the library, our model is saved under content /runs, under detect, under train, and it's saved within best.pt. So weights, we'll use the best.pt model. So this time I'm using my own model, and then we go metrics, model.val, and then I print metrics.box.map. So this will give me the statistics of this model. Okay, so now that we have the statistics, we can see that our model so far looks fairly accurate with the R and the P values. So this time let's perform inference. So I do model equals, let's just bring this up again. I'll just copy it like so. I'll paste it here, and I want to get my results. So let's take an image that we want to perform inference on. Let's take from archive. Let's go to images. So let's take 003.jpg. So I copy path, model.jpg. So now this will perform inference on this model, and hopefully we get an accurate result. So now if I run it, let's see what we get. Okay, I forgot to print the results object. So results. Okay, so now we have a lot of data here. So here we can see we have a list of result objects. And since we have only one image, I think it's safe to just go results, and then get the first or the only item in this array. So instead of results, it's result. And if I run it, and here we have this boxes object, which I think contains the classes and the confidence scores of the labels in this image. But let's just do result.show. So hopefully we can see our resulting image. Okay, so now we have our image. As you can see, it's completely correct. We have a 2-cent coin, and the model has predicted the coin accurately. So we can do another code snippet. Let's try to get the class and the confidences via code. So I go class predictions equals results.boxes.cls, and do confidences results.boxes.conf. So this is the confidence, and this is the class label. Okay, so we have an error. I made an error here. So it's not results, it's result here as well, and then run it again. Whoops, I forgot to print it. So print class predictions, and I print confidences as well. Okay, so now we have our class. So in this case, the class ID of the 2-cent coin was 1. And there's a 98% confidence. Let's go up and let's do inference on another image. For example, let's take 010. It's still very much accurate. Let's run it again. Let's try finding an image with multiple coins. So I know 054 has one. Nice. It's very much accurate. That makes me really happy. Now let's run this code snippet, and now we have 2 classes with their corresponding confidences. Let's now write more code to make it look a bit more cleaner. So they return tensor objects, so I want to turn them to a list. So dot to list. Same for the confidences, to list. And if I run it again, we now have an array. So here my intention is, instead of the class ID, I want to get the class name. So for example, instead of 6, I want €1. And how many times did we have the same coin? So let's try doing something. So I go predictions and let it be an object. So for class ID, comma, confidence, I use a zip. So in zip, so this will merge both of these arrays. Class predictions, we have AI here, and then confidences. Okay, so now we have autocomplete. I can create another variable for my class names. So class names. So I remember the first one was 1 cent, the second one was 2 cent, the third one was 5 cent, and then we had 10 cent, 50 cents, or cent, €1, and €2. Great. So let me remove this like so. So let me check if my class names exactly matches my ID. So I'll go class name is equals class names and then the index. So in this case it's class ID. So I go class ID and then I can go print a template literal class name space comma and then it's confidence or it's associated confidence. Let me run it. Okay, so we have an error here. It's because my class predictions contains float values. So I have to cast it into an integer. So int like so. And then let's run it again. So €1 has a 0.98 chance and a 5 cent has a 0.98 chance. Yeah, that's really good. So I also want to filter out all the confidences that are below 0.5. Or in other words, if my confidence is more than 0.5, I get the associated class name and then I do predictions and then the key. So class name, so I want the key and then the count. So I want the key and the value of this key is going to be how many times a coin was found in the image. So predictions dot get class name. So if it does exist, I get the value. Otherwise, if it does not exist, the default value is going to be 0 and I add 1. So if it does exist, I add 1 and then I can do a print of predictions. Let's run it. Great. This seems really good. Let's test out another image. So I found an image 138.jpg. So I just copy this code like so and then make another code snippet. So instead of 054, it's 138. Result.show. Let's see what it says. Nice. That's very good. Our results are very much accurate. And then we can also get the count. So I'll just convert this code into a function. So def get predictions. Actually, you know what? I'll just remove it. Let's copy it. Here I can put it into a function. So def get predictions. And the argument is going to be a result. Let me just fix the indentation. And yeah, here we can get the predictions. Let me put the predictions here. Fix the indentation once again. Let's double check. Okay, this seems fine. Let me run it and see if anything's wrong. No, nothing's wrong. Here I forgot. Instead of print, it's going to be return predictions. Let me remove this and then let's run it again. Okay, it seems fine for now. And then get predictions. And then my result, which is this result. So result. Great. As you can see, our output was pretty much accurate. Let's try exporting this model into other formats. This will allow you to run this model on other hardware. So model, actually we do have the model instance. So I just go model.export and then we can have any format we want. So for example, let's do on X. So this means that you could run your model on a Raspberry Pi. And if I run it, hopefully it should work. Okay, it's going to take some time. Let's wait for a bit. All right. A few seconds later, we're now done here. So our model is saved under runs, detect, train, weights, and best.onX. Great. As you can see, our code worked. In this video, you guys learned how to get started with the YOLO model. You first learned how to use Label Studio to label or annotate your images. And furthermore, you also learned how to train the YOLO pre-trained model on your dataset. That's it for today. If you guys have any questions, let me know in the comment section below. I'm also open for any ideas or your feedback. Till then, bye bye.